There's editing, but only to like turn up the volume on any mistakes that you make.
Yeah, I think we have enough now for I love Linux. This episode is sponsored by Front End Masters. They have a terrific lineup of live courses you can attend either online or in person. They also have a terrific backlog of courses you can watch, including JavaScript The Good Parts, Build Web Applications with Node.js, AngularJS in Depth, and Advanced JavaScript. You can go check them out at frontendmasters.com. This episode is sponsored by Hired.com. Every week on Hired, they run an auction where over 1,000 tech companies in San Francisco, New York, and LA bid on JavaScript developers, providing them with salary and equity up front. The average JavaScript developer gets an average of 5 to 15 introductory offers and an average salary of $130,000 a year. Users can either accept an offer and go right into interviewing with the company or deny them without any continuing obligations. It's totally free for users, and when you're hired, they give you a $2,000 bonus as a thank you for using them. But if you use the JavaScript Jabber link, you'll get a $4,000 bonus instead. Finally, if you're not looking for a job but know someone who is, you can refer them to Hired and get a $1,337 bonus if they accept the job. Go sign up at hired.com/JavaScriptJabber. This episode is sponsored by Wijmo 5, a brand new generation of JavaScript controls. A pretty amazing line of HTML5 and JavaScript products for enterprise application development in that Wijmo 5 leverages ECMAScript 5, and each control ships with AngularJS directives. Check out the faster, lighter, and more mobile Wijmo 5. This episode is sponsored by DigitalOcean. DigitalOcean is the provider I use to host all of my creations. All the shows are hosted there, along with any other projects I come up with. Their user interface is simple and easy to use, their support is excellent, and their VPSs are backed on solid-state drives and are fast and responsive. Check them out at DigitalOcean.com. If you use the code JavaScriptJabber, you'll get a $10 credit. Hey everybody, and welcome to episode 184 of the JavaScript Jabber Show. This week on our panel we have Dave Smith.
Hello!
Jameson Dance.
Hello, friends, and also enemies.
I'm Charles Max Wood from devchat.tv. Just a real quick plug for JS Remote Conf if you want to submit a talk or buy a ticket. We also have a special guest this week. That's Nik Molnar. Did I say that right?
You did, perfectly.
Do you want to introduce yourself?
My name is Nik Molnar, said the exact same way. I live in Austin, Texas, and I'm a web developer and a program manager at Microsoft on the cross-platform and open tooling team.
Can you just explain a little bit about what that team does?
Sure.
They cross platforms and open tooling.
Yeah, I was about to say, the name is right there on the tin. Well, so that means that the products that team is working on and focused on are cross-platform, meaning running Linux, OS X, and Windows kind of by default. I work on a web product, so that also means cross-browser by default. And open, meaning that everything that we're doing is open sourced or is involved with open standards, like some work with the WC3 or other standardization bodies. And that's really our focus. And then we also serve as kind of a function at Microsoft to help other parts of the organization to think about and embrace open source, either consuming it or shipping it.
So my outsider's impression is Microsoft has moved to embrace that. Is that still a big transition for some people inside Microsoft, or is it kind of just how things work there?
You know, I don't think I can speak to that expertly because I've only been at Microsoft for 3 or 4 months now, and it's a huge organization, obviously. So I think that your experiences may vary depending on what parts of Microsoft you work in. I'm in the Cloud and Enterprise division, and so that's the group that brings you .NET, Visual Studio, a lot of other developer-focused products. And I think that division is very well aligned in embracing open source now. And so I think that you should continue to see us move forward and evolve in that space.
Yeah, I remember when Microsoft was like the evil empire and, you know, oh, Microsoft. But it seems like they've really kind of opened up and said, you know what? There's a real ecosystem out there beyond just the Windows Server and Microsoft Desktop arena. And there are a lot of things that they've put out there. One of the things that I know that they did, we did an episode on it on Adventures in Angular, was Visual Studio Code. And all of the people that I've talked to that are using it and loving it are on Macs.
Yeah, exactly. Visual Studio Code is my team. Not my immediate team, but the guys in my group puts out Visual Studio Code. And it's great. I use it. It's actually, you're stealing my thunder. It's one of my picks for today's episode because it's great for JavaScript. Use it for Node, for front end stuff. It's really fast and lightweight. I'm really enjoying using it over some of the other similar text editors like Brackets, which I was trying to use before, but I wasn't super successful with.
So I think we brought you on here to talk specifically about performance. Is that right?
Yes, that is mostly what I focus on and care about. And the product that I work on, which is an open source debugging and diagnostics tool called Glimpse, its main use case is around performance. So I've kind of been entrenched in the performance space, particularly web performance, for almost 5 years now.
This is, I don't know, it's kind of a hard topic to give an introduction to, right? How do you introduce performance? Computers are fast, but sometimes we write slow code.
It's very easy. You just introduce it very quickly.
Ready for the most performance talk you've ever had? Well, so the way that I like to do it is I have two main talks that I do. Each are an hour long. So obviously we don't have the time to cover all of that now when I talk about web performance. But one of them really digs into how to measure web performance and what to measure. And the other one digs into, okay, here's the common problems and how you would fix them. So we might want to start to talk about why performance even matters. Maybe your audience already agrees that it does, and so we can skip that. And if not, then we can dig straight into what to measure and how to measure it. Whatever you guys are more interested in, you let me know.
I think why it matters would be important. I think you might have people that think computers get faster every year, or they have gotten faster every year, especially in the browser. VMs get faster every year. So, I mean, you just wait and then your performance is better.
Yeah, that is an approach. That's an approach that we used for a long time. Unfortunately, we're kind of at a bottleneck with web performance, and specifically because the big bottleneck there tends to be latency, and latency is not really getting much better. And so there's techniques that we can use to kind of get ourselves around the latency problem.
So when you say latency, you mean the round trip time to talk to a server and get a response, right?
Yes, exactly.
So you're saying that Moore's law does not apply to the speed of light?
No, it does not.
That's just because the high frequency traders have not figured out how to make money off of making Moore's law apply to the speed of light yet.
Oh, trust me, the high frequency traders, they think about the speed of light all the time. When I was living in New York, I did a lot of consulting for banks, and literally the office they would pick, and based on how close it was to the next major internet hop, that was a competitive advantage for these companies.
Oh my gosh.
They're responsible for laying a lot of fiber optic cable, if I understand correctly.
Yes, you are exactly right. Milliseconds, nanoseconds, that kind of stuff matters. It leads to some very interesting and ugly architectures. They're not the clean architectures that you would like to build as a purist software developer, because you're like, extra hop, extra call. Nope, not going to do that. Inline everything. And it's like, oh, this code is a pain to work on. But
so maybe that's a good question to open, but to open the topic. But is good, clean architecture, generally speaking, at odds with high performance code?
It's a really good question. And I would have to say, to a degree, yes. There is a lot of things that you would do, right? So let's take an example, right? One of the most simple things that you can do in web specifically is to bundle and minify your assets, right? So take your JavaScript and your CSS, you minify it, you strip out all the white space, and then bundle it, meaning if you have 2 or 3 CSS files that you might have split up for modularity purposes, for example, jamming those things all together. Now, why I say it might be at odds is kind of slightly is because what I'm describing to you there, that is the distribution, right? If the web was binary, if it was compilable, we don't really think about what the compiled code looks like in a native application. We only care about the source. Mm-hmm. However, because of the way the web works and the stateless nature where there's a server and a client, there's a lot of times where we're using our clients and the debugging tools built into our browsers to look at that JavaScript, to look at that CSS. And so when we pop it open and it no longer resembles what it did when we wrote it, that does kind of make the architecture a little less clean because we've made this optimization to improve performance, but now it's a little less debuggable, maintainable, etc.
So you start talking about latency, and that's not a thing that gets faster as processors get faster. What do we do about that?
Oh, and we got to talk to some physicists about that. So I mean, when we think about processors, so let's break down the way that a page renders. All right, so the very first thing that typically happens is your browser will issue a request. Issuing a request means we're going across the network, right? So right there, the very first bottleneck we might hit is network. On the other side of the network, the server receives the request and it does some processing. Maybe you're using, PHP or some templating language or something like that on the back end that has to build up the HTML. Once that is done, the HTML is really kind of, it's a honey-do list, right? Every Saturday, my wife tells me, here's the things that I need to do. I got to go cut the grass and I need to go pick up milk and do this, that, and the other. HTML is really just a to-do list for the browser. And so the server puts together the honey-do list and it sends it down to the browser. And then the browser says, oh, okay, well, now I need to go and I need to download these JavaScript files and I need to download these CSS files and I need to go download these images. And so once again, we're hitting the network there. And once it gets all of those assets, it has to render them or execute them or parse them based on the type of asset. So when we talk about CPU performance and Moore's law, that does apply to things like server-side rendering time, right? The PHP chunk that I mentioned there. Mm-hmm. And it applies to the JavaScript side if you're running custom code on the client. But all of the in-between time is latency. And so the closer we can be to the server, or the faster that connection between the client and the server is, the better the latency. So let me give you an example. I just did a quick little performance audit of your guys' website, the JavaScript Jabber site, chat.tv. I won't shame
the
anything.
Cobbler's children.
You shame away. I wrote it myself, but go ahead.
So
you wrote that, Chuck? I was wondering who did that.
Yeah.
I wasn't even sure if this was like a CMS that you guys were like built in with because it's dev.chat.tv. Anyway, there's 17 JavaScript files that are there. So the round trip.
Chuck.
Chuck, what are you doing? So the round trip time happens on every single one of those requests. And so if we can eliminate latency, then that wouldn't be as much of a problem. And so when I say that we have to get physicists involved, it's because assuming that we're on fiber optic, which obviously most of us aren't on fiber optic from end to end, but even in fiber optic, at this point, we're only getting about 2/3 of what the speed of light is in a vacuum. And so there are universities working on this problem, trying to eke out additional percentage points on the speed of light through fiber because it matters. And if you compare latency to bandwidth, there's been studies that will take a large group of websites and they will increase the bandwidth and reload the website over and over again. So 1 megabit a second, 2 megabits a second, et cetera, and see how long it takes to load each of those sites. Bandwidth does matter for common web sites up to a certain point, but then it has a huge diminishing law of returns. When you start getting, everybody's talking about, oh, I want Google Fiber or I want Fios. And the reality is if you're mostly just surfing the web, you're not going to see much of a difference between the two. That comes into, watching video and doing other bandwidth heavy things. Whereas latency doesn't. Go ahead.
Can you define what bandwidth is too? We've talked a little bit about what latency is, but just to make sure everyone has we're working off the same knowledge base.
Yeah, for sure. I think of bandwidth as capacity, right? So bandwidth is when your city decides that to get traffic moving more quickly, they're going to add another lane to the highway. Now, instead of 3 cars wide at a time, it can be 4 cars at a time. So it is the capacity, it is the amount of cars that are able to travel down that street at the same time. Whereas latency is a Pinto versus a Ferrari. And it doesn't matter how many lanes there are, it's how fast can you get from point A to point B. Does that illustration kind of clear up the difference between bandwidth and latency?
Yeah,
sure.
Yeah,
that's great.
So it's bits per second versus milliseconds round trip time, right?
Exactly. And it gets really confusing because if you turn on the radio or whatever and hear any of your broadband providers, they tell you, well, our speed is 100 megabits a second or whatever it is. Well, that's a lie. That's not their speed. That's their capacity. The reality is if your capacity gets choked off, it will affect your speed or your latency. But they're kind of two independent things that sometimes step on each other.
Okay, I totally cut you off, though. You're in the middle. You're building up steam, and then I dumped a big bucket of water on your fire.
Yeah, now I'm trying to look at the coals and remember where I was going. Yeah, so the question was...
Hold on, I think we're in the middle of criticizing Chuck for writing a slow website. Can you go with that?
I know. 17 JavaScript files. I mean, it takes 20 years, right?
Well, there are certainly things that you guys could do to improve it. I think one of your challenges is most of those JavaScript files seem to be being served from different service providers. I see a lot of Google, I see Add This, I see Stripe, I see Track.js, et cetera, et cetera. And so you guys have extra challenges because you're relying on services. And that's really common in today's kind of mashup, I'm showing my age to say that word, mashup internet, right? Where we're cobbling together these different services.
So you're going with the honeydew list, and the server gives you a bunch of HTML, and you're waiting for it to come back, and then
yes, that's where I was.
Next?
Thank you so much. So everything comes back to the browser. It goes off and downloads all those things. So the CPU, we were talking about Moore's law. That applies on both the server and the client executing the JavaScript. But the network is usually the thing that you want to optimize first. So the studies show that the 80-20 rule applies here. About 80% of the performance problems that you'll see in web applications can be solved with networking optimizations. And the study was recently redone with a focus on mobile, but it goes from 80-20 to 90-10 on mobile because those networks are so deficient compared to what we're getting on a standard kind of desktop machine. So for example, with these files that you guys have, I think the biggest single thing that you can do on your website is to enable caching of all of these assets. Right now, there's very, very few files being cached, so I'm downloading them again and again each time I click on another link on the page. Whereas if I could cache them and not have to re-download them, what that does is instead of me having to deal with latency, I can just skip it because I'm going to read it from disk instead of going across the network again.
So you're talking client-side caching?
Yes, HTTP level caching. And so usually you just go into your web server, there's a configuration file where you can add a configuration header, and that header will tell the browser, hey, listen, this file here, it's good for the next week, 10 minutes, whatever you guys deem to be appropriate, and then the browser won't download it again for that time frame.
Oh, yeah, there's a new episode every 10 minutes.
Yeah, perfect, exactly. Yeah, I would imagine you guys could get away with weekly caching, and some assets probably longer. Like, I don't think you probably change your logo very often, so cache the logo for a month, 2 months, something like that.
Yeah, that makes sense.
So now, some people might say, okay, none of this really matters. And this goes back to what we originally were thinking. Well, why does performance matter? There's been all the big companies have done studies on performance and what it does. So Amazon added 100 milliseconds of load time, and they lost 1% of sales.
Oh, wow.
So 100 milliseconds, this is a number that's so small that it's kind of hard to think about. We don't really deal with much of anything, maybe millimeters once in a while. So what I want you to do is I want you to blink your eyes. That blink just took between 300 and 400 milliseconds. So 100 milliseconds, and Amazon lost 1% of their sales.
I'm literally sitting here blinking as fast as I can.
I've been training my blink reflexes for a long time, and I can tell you I can blink in like 100 milliseconds.
You're like, 100 milliseconds. Well, that's still 1% of Amazon sales. So.
Jameson has a superpower.
Yeah. At Google, they did this experiment where they increased the number of results that were being shown on their search results page, and that ended up adding an additional 500 milliseconds, so half a second, and they lost 20% of their revenue and ad click-throughs because of that. So 500 milliseconds, 20% is pretty big. And then another study done by Etsy, they added 160K of hidden images to their page, and their bounce rate increased by 12%. That means the number of people that went to that page and no others went up by 12%.
Oh, man.
And it's easy for me to spout figures. And these companies care because they're selling something, right? Like, bottom line matters. They can tie performance to revenue. And, a lot of the users, and myself included, I haven't worked on a ton of e-commerce websites, but I certainly have worked on content websites and things like that. And this stuff matters for content as well. Google has added a factor into their algorithm for page speed. And the faster your site is, the higher up in the index you'll move. So you get more traffic if you're faster. In fact, they're experimenting. This popped up, I believe, in December of last year with what I call the scarlet letter of the web. They've put this little red slow icon next to websites that they deem to be too slow. And I think they were A/B testing that. You certainly don't want that to show up. Yeah. And then lastly, the thing that I'll say is, more and more, and maybe even a majority of the time now, your website is accessed via a mobile device, right? I'm holding my iPhone in my hands right now, and these devices are underpowered compared to what we've been working on. They've been out for 5 years or so, which is quite a while in internet time. But before that, we kind of didn't worry about performance that much because bandwidth was getting so good, and Moore's law was there. And now it's not, because people are using these things. And so there are certain websites that I know if I go to and I'll read an article, I can see my battery drop 10, 15% just because I'm reading an article and they're doing really dumb things with their CSS and all these extra animations and things like that.
It's on scroll events, I guarantee it.
Oh man, those are the worst. Honestly, that's one of the worst things that you can do. Just get rid of on scroll events. If you can avoid it in any way possible, talk to your designer and get rid of on scroll events. And then lastly, I mean, those are really good audience and financial reasons to consider performance and make sure that your applications are as performant as possible. But performance should not be your number one concern, right? Donald Knuth was famous for his quote about premature optimization is the root of all evil in software development. And so, I kind of want to put a little gut check in for the listeners to not just run off and say, oh my gosh, we're going to increase our sales if I go and I make this thing faster. What you really need to think about in your application is there's this hierarchy of needs. And we're familiar with Maslow's hierarchy of needs, potentially, right? He's a psychologist who said that there's certain fundamental needs that humans must meet first before they worry about more advanced needs.
Yeah, so it's like the triangle with Wi-Fi on the bottom, and then
exactly everybody puts the
about
Wi-Fi.
Self-actualization on Medium on the top.
Exactly. So there's the UX director of MailChimp in Philadelphia. His name is Aaron Walter. He's proposed a similar pyramid, which is the hierarchy of needs for users of software. And so the very first thing that your users need out of your software is they need your software to be functional. It has to have a problem. It has to solve a problem that they have. And then next, it kind of needs to be reliable. It needs to do that without crashing all the time and in a consistent manner. I'm on Twitter quite a bit. My handle is Nik, N-I-K, MD23. And a few years ago, you guys might remember that Twitter was so notorious for being unreliable that their mascot, the fail whale, kind of became famous in and of himself. Mm-hmm. And so during that time when Twitter had reliability problems, I didn't really use it because it didn't meet that second level of the hierarchy, which is reliability. Now, Walter goes on to suggest that the next level of the hierarchy is usability. And there's been a big shift and a big focus on design and UX in our industry, right? I maybe give Apple some credit for that with what they did with their devices, but everybody really cares about design now. But part of usability, and this is the part that I add into the hierarchy, is performance, right? If it's beautiful, but I can't access it quickly enough, then I'm not going to use it.
So, when I hear about performance as usability, I think of, you mentioned those on-scroll things. I've seen a lot of beautiful PR sites where there are amazing things happening when you scroll down the page, just these gorgeous animations, but it hijacks your scroll and then it feels broken. And then I don't like them anymore. Like there's a little angel flying across the background, but when I scroll down, it doesn't scroll down. Like why? I don't care. I don't want that angel there. I want to scroll down. That's why I'm scrolling down.
Yeah. You will scroll the angel and you will like it.
Yeah. I didn't press the show angel button. I pressed the scroll down button.
And I would assume that if that was the only way to get to the data that you need, you might deal with it. But if there was a competitor that could give you that same information that was functional, reliable, and usable, you would switch over to them. Because the switching cost on the web is so cheap, right? I Control L, I type in a new URL, and I'm gone. And so you have to really be invested in getting those users. So Walter's hierarchy goes on to finish. The top of the pyramid is that we can begin to create pleasurable software. And this is software it is functional, it is reliable, it is usable, it is performant, but it's also pleasurable. And so you see that in really beloved products that we all talk about, like GitHub or Trello, where the personality of the team is coming through in fun little ways. And so we get, Octocat Jedis on 404s for GitHub and a barking dog named Taco on Trello, right? Like we can see that team, and it's kind of fun to use those apps and see what kind of happens because they've made it to the top of this pyramid and now they're doing pleasurable things.
That's a really hard place to get in my experience as a developer.
Yeah, I don't know that I've ever gotten there. I was just thinking about that.
I completely agree. I don't know if I've gotten there either, but I'm trying to get there. And that's why performance has been, kind of my focus for the last five or so years.
Another appealing thing about performance is it feels like as a developer, I have a lot more control over the performance than I do over the pleasure that people get from the app, right? Like there's a spectrum of how involved developers are with customers and project management and things like that. But I think even if you're heavily involved in the direction of the product, if you're the one building it still, it can feel like this amorphous mass of desires. And it's hard to say like, yep, I nailed it when you're down in the code, I think. But the performance, you can measure it and you can say, yep, it's faster. I did it.
Yeah, you're exactly right. I think the only time that developers maybe have trouble controlling the performance is when they work in a team where they are the development team and the UX team is another team. They throw things over the wall. And that, from a cultural standpoint, is dangerous. Performance is something that ideally the entire organization would be bought into from top to bottom. And there's a concept called the performance budget, where everybody would agree, just like, we don't want any bugs, and there's this criteria for what makes the software of good quality. There's criteria for what makes software performant. So you might say, and we haven't really talked about the different metrics that are available, but you might say something like, well, our speed index is going to be 2,500 milliseconds. And that's the budget. And if the designer designs something that there's no way for it to be implemented in that time frame, then we all agree as an organization that we're not going to implement that feature, at least not in the way that it's designed right now. And so I agree with you that developers typically have a lot more control over the performance of things, but if they're not working closely with their designers, that can get away from them rather quickly.
So I want to ask about a couple of things. The first one is, you mentioned the examples you mentioned on performance were in e-commerce websites where there's a very direct monetary cost to performance, where, there's the bounce rate goes up. Bounce rate going up means you make less money. There's a whole other world of applications. Especially enterprise apps, right? If your company has bought this application and you have to use it to get your job done, to some degree, performance doesn't matter as much, right? It'll make your life better if it's faster, but if you have to use it, how do you justify spending time on performance if it's already okay-ish in a situation like that, where you're the company making this enterprise software?
It's certainly something that needs to be balanced and considered as ROI. So when I was consulting, I did a bunch of these, corporate intranet type applications that maybe had somewhere between 20 or 2,000 users, pretty small on the use case scenario. But a lot of times in those places, management would say to me, well, as long as the page loads in 30 seconds, it's fine. It's only used by 50 people. And so, what good enough is in your scenario, I'm not sure. But the easy thing to do there is, if there's an action that those 50 people have to take every day and it takes 10 seconds, but you could whittle it down to 5 seconds, it's easy to do the math and say, well, these 50 people times 5 seconds times 365 days a year times their average salary, and you will get a number that's in the thousands. Now, does it make sense? Would it be cheaper for me to go and fix that and whittle those 5 seconds down? Would it be cheaper than the thousands of dollars that we're going to spend over the next year? And how long is this software supposed to last for? Because usually those systems are built to last for 5-10 years. And so I think in that case, it's very easy to make the ROI decision on whether or not you should be investing in a particular performance scenario.
Yep. Now, the scenario you just described sounds kind of like a linear relationship between the amount of money that it would be worth to whittle the performance down. In my experience, it seems like it's more of a step function, which is like at some point the user becomes distracted and they go do something else while they're waiting for your page to load. And then it doesn't matter if it takes 2 seconds or 10 seconds if the distraction point is at 1 second. Have you any experience with that sort of measurements or research?
Yeah, I know the research for when users do get distracted as far as calculating ROI because they've switched tasks. I know generally that all of the research shows that context switching is very bad, and it takes a lot of time to do that and to come back to a task. The math behind that is above my pay grade and my Algebra 2 schooling. So, but basically, as far as when people begin to lose interest, the studies were done in 1968 at IBM. And the same study was reconducted by Jacob Nielsen again in 1993 and in 2005. And the numbers didn't change over those 40 odd years. And so basically what that comes down to is 100 milliseconds, right? The number that we talked about earlier, that feels instant to a user. So I'm not saying that you need to respond to a web request within 100 milliseconds, because best of luck to you making that happen. But if I go in and click a button on your site, that button needs to press, right? It needs to be a sad button, or it needs to say loading, or it needs to disable. It needs to do something within 100 milliseconds to let me know that I got the gesture. And you know the sites that don't do that, because you'll click on something and you're like, oh, maybe my mouse is broken or the batteries are dying, and you go and you try to click again. That's the 100 milliseconds, and that feels instant. 1,000 milliseconds, 1 second, is uninterrupted thought. So if I can click on that button, one Mississippi, and I'm seeing the response come back, you're never going to lose your user. They're still focused on the task that was at hand. Now, the study went all the way up to 10,000 milliseconds, up to 10 seconds. At 10 seconds, not one user in any of these 3 repeated studies still had their attention on the task they were trying to accomplish. The numbers around 3 seconds are where people will start to leave now, but at 10, for sure, you've lost even the most patient of users. And so, maybe in your experience, because I'm going to speak to your experience now, since that's what you asked me to do. Maybe in your experience, switching tasks and firing off something and letting it run and coming back to it later is fine. And you know what? There are tasks that just take that long, right? Maybe you have a huge amount of data to crunch, or you're waiting on results to come in from the field, or something like that. And that's fine. But what I would recommend doing in those situations is responding quickly and acknowledging the user's gesture. And then if it's going to be a while, find another way of notifying them, right? There's notification APIs built into HTML5 now. You can email your user. Maybe you can tie in an I am their user in a corporate setting. Like, there are ways to draw them back into the activity and just kind of acknowledge, hey, listen, I can't meet these kinds of demands that Nik's talking about here, right? These 1,000 milliseconds uninterrupted thought, that's fine. Let me find a way to release my user's psychic weight so they don't have to think about this anymore, and draw them back in later when I'm ready for them.
Or maybe just present Flappy Bird to them to keep them busy, right?
The old Chrome 404 page model.
Yeah.
Hey, it's broken, but it's entertainingly broken.
You could that's personality coming through. You could definitely do that. I think that calculating the ROI on that might be a little bit easier. So I mentioned a term here called speed index. Is that something that you guys are familiar with?
No, I'm not.
Okay, so I think that this is something important, because what I find that when people dig into web performance, one of the problems they run into is there's hundreds of different metrics that might or might not be useful. And so Tim Kadlik is a well-known developer in the performance space, and he's kind of broken down all of these metrics into 4 categories that I really like. And so the first of the metrics is quantitative metrics, and these are the metrics that maybe you've heard of before. They're very simple, basic numbers. So they're things like page load time, page weight, number of images, number of HTTP directs. They're all just simple numbers. But the problem with them is, if I tell you that there's 17 JavaScript files on your page, that doesn't necessarily mean that it's slow. We have these gut reactions. That number sounds really high. But if I tell you I have 2 different pages and one has 3 JavaScript files on it and one has 2 JavaScript files on it, you don't actually know which one is faster, because quantitative metrics don't tell you anything about performance. So the next category of metrics are rule-based metrics. And what these really kind of do is they look at your quantitative metrics, they run some analysis on top of them, and apply best practices. So if you think about tools like Yahoo's YSlow or Google's PageSpeed, that will literally give you a grade and say, hey, your website is an 88, or your website gets a B. Those are rule-based metrics. And they typically tell you, well, maybe you would have had an A if you cache these resources, or if you minify this JavaScript file, et cetera, et cetera. But just because my website is an A, that doesn't mean that it's fast. It just means that I'm following the current best practices. So people like to use rule-based metrics because it's kind of one number that you can rally behind and point your boss to it. But like I said, it's not really telling you anything about the performance of the site. For that, we have to start getting into milestone-based metrics. Milestone metrics measure the amount of time between when a navigation began and some processing event that happened in the browser. And so there's a couple of famous ones for this. So you might have heard of time to first byte. That's from when I click on the link, how long is it until the server responds and I get the first byte of the response? But there's also time to first paint, how long until the first pixel actually renders on the screen. And then the 2 most famous milestone metrics, because they're built into all of the developer tools, is the time to DOM content loaded and the time to load. But a lot of people don't even understand the difference between those two, DOM content loaded and load, right?
DOM content. I was going to ask you, go ahead.
Yeah, DOM content loaded is when the HTML has finished downloading and the browser has parsed it and has turned that HTML into a DOM, and you are ready to begin manipulating with it. It does not mean that all of the rest of the assets on that honeydew list have been downloaded. So you might still be waiting for JavaScript and for images and things like that before when DOM content loading hits. But in time to load on the onload, now all of those assets have finished downloading. And then maybe you're going to go and kick off some more with JavaScript or something like that. But that's kind of out of purview. And so milestone metrics are really great because they get down to performance. I can say this took 1200 milliseconds and now it takes 800 milliseconds and it's faster because I'm talking about time and speed again. But the problem is they're extremely technical, right? Even here, I had to explain the difference between DOM content loaded and onload. And I don't even know if I did that great of a job explaining it to this technical audience. So imagine having that conversation with your non-technical manager. So some people have tried to make custom milestone metrics, which is a little bit better. So Twitter is famous for this. They have a metric on their page, which is time to first tweet. How long is it until the first tweet of your timeline appears? Or you can imagine YouTube having time to video playback. How long until the video starts playing? And those are business specific, right? Twitter is in the business of serving tweets and YouTube is in the business of serving videos. And so making those metrics specific to the business helps everybody get behind that culture and helps everybody understand, especially when you're starting to put together something like a performance budget. Now, one of the challenges around milestone metrics is I could have a site and you guys could have a site and we could both have an onload time of 3 seconds. But I'm kind of this old school guy. Maybe I just did everything on the back end. And at 3 seconds when onload hits, my user can see all of the content. But you guys do really cool things with Angular and React and Ember and who am I leaving out? Whoever else.
We use them all. We use all the front end frameworks.
You use them all. So
it's a JavaScript podcast.
So when you guys are using Fluxembular, that's my .js, that's Nik's new framework. When you guys are using that at 3 seconds, you hit onload. Maybe there's not actually a lot of content there because that's the moment in which you start Ajaxing everything in. So even though we have the exact same onload time, the user would perceive our pages to feel different. They would perceive my page, the old-fashioned, boring one, maybe to be a little bit faster. And so the fourth and final category of metrics are these perceived metrics where we try to measure the way that the user feels about how fast the page loads. And so Google and Microsoft and a bunch of other companies have tried to come up with perceived metrics that have mostly failed because they've been very difficult to calculate. But there's one that's kind of still hanging on, and it's what people are rallying around. And that's the one that I mentioned before. That's the speed index. And so what the speed index does is the engine that calculates it is at WebPagetest.org. And so what that does is it captures a video playback of your page loading, and it looks at frames every 10th of a second, and it calculates how visually complete is that frame to the final frame. And so it builds a score. And it charts those percentages over time, and that makes a curve, right? So we might be at 0%, 0%, 14%, 56%, 97%, 98%, 100%, right? And so we get this little curve if we plotted that out. You take the area above the curve, and that's what makes the speed index. That's all very mathematical and weird sounding, but basically it's how much of your site got to your user how quickly. And so, for example, the JavaScript Jabber site has a speed index of around 5,000 milliseconds. I did 9 loads of it and it came up with a median run to get that 5,000. That's on the first load. And so that metric, that's the one that I really recommend that if you're going to think about